finally, for this unit, talking about inverse functions, we have introduced them before when we're talking about the exponential and the logarithm. So how to define the inverse function? Okay, so I'm going to introduce a new function that I'm going to call the identity, and the identity is just the function that assigns the value x to the input. Okay, so the same output as the input. Okay, so now if we have any function f that goes from its domain a to r, then our function f minus 1, okay, and we call this the inverse of f minus 1, is a function that goes from the image of f to the domain, or well, if you in general a real number. And so the assignment is x, and then you get f minus 1 of x. But the property is that when you compose these two functions, so f composed with f minus 1, and in this case you have a commutative property, what you get is the identity. Okay, so f of f minus 1 of x is x, and f minus 1 of f of x is x as well. Okay, so I have x and y, and x is mapped to y by x, then y is mapped to x back by f minus 1. Okay, so it's this kind of idea that as I told you when we were talking about the exponential and the logarithm, if you have this point x, f of x, then the equivalent point is the point f of x in the inverse function. Okay, so this is e to the x and the logarithm of x. Okay. Inverse functions are interesting in that when you are, for instance, a function like x squared, right? If you want to define a function, an inverse function, so if I have you, for instance, f of x is x squared. Okay, now if I give you a given y, I say this is y is x squared, can you give me f minus 1 of y such that I get the original x? Okay, but the problem here is that there are two possible x's for this. Okay, so then you have you could have square root of y is x, but minus the square root of y is also an x that when you square it will give you y, right? So you have two possible values. And then you can't define an inverse for the whole of the domain. So when you have a function like this, and this is when functions are not injective, okay? So this happens when functions are not injective. Then you have to restrict the domain of the function that you need to compute the inverse of. Okay, so for instance, in x squared, the typical case is to start from 0 and then just consider the positive part, and then the inverse of that is square root of x. Okay, but only works for the positive half axis. Okay, but if a function is injective, then you can compute an inverse for the whole of its domain. Okay, and so that's why the exponential has an inverse, which is the logarithm. Lines have inverses, for instance. So for instance, if you write y equals ax, so what's the function f minus 1 of y that gives you x? Well, you have to solve for x here. So x is y divided by a. So f minus 1 is, and then y of y we want, is 1 over a of y, for instance. Okay?